Hello, everybody. So today we're going to start into Chapter 0, Section 4. And what Chapter 0, Section 4 deals with is measures of central tendency. And mainly we're going to talk about mean, median, and mode. So for a lot of you, you have actually already done this before. So this should be a fairly easy section for you. So let's take a look at the first example. So they give us this chart here that says the percent of active iPhones, and that is global. And you can see they have different countries listed there, and then they have the percent of phones that are active after 1 month of this particular phone model being released. And so you can see that what they have listed here is a very nice visual way for us to see this data. Other than just writing numbers down, they made a bar graph so we can see what country has the most and see how they compare to the various submodels. You can see one's an iPhone 5C and one's an iPhone 5S. But the point of this is for you to be able to visualize the data very easily, so you can make sense of it. And that's what we use measures of central tendency for. And we have various ways to do that, whether it be making a pie chart or making a bar graph or even making a scatter plot. So it just really depends on your data and how you want to represent it as to how you would present it. So looking at this first example here, they want us to find the mean, the median, mode, and the range of our data that we have right here. And you can see that we have the teams played and then the number of hits that each team has. And so we need to first make sense of what each of these words mean. And so our first word here is mean. And what they want you to do when they ask you to find the mean is add up all of the data points that you have and then divide by how many data points there are. So you can see in this case, there are 6 data points. So to find the mean, we would simply add all of those points up. So we're going to do 3 plus 6 plus 5 plus 2 plus 3 plus 7. Now, once we add all of those numbers up, we will divide it by the total amount of numbers we have. In this case, there are 6 numbers. And so what that gives me, 3 plus 6 is 9, plus 5 is 14, plus 2 is 16, plus 3 is 19, plus 7 is 26. We end up with 26 over 6. And if we were to divide that on a calculator, 26 divided by 6, we get 4.3. So the mean of our data is 4.3. So what that's saying is the average number of hits that each team would have gotten was 4.3. Now the median is, I don't know, you could say it's easier, maybe it is, maybe it isn't. But to find the median, you actually have to list all of your data points from least to greatest. So in this case, we'll start with the smallest, which is the Vikings. And as I use them, I'm going to cross them off. And then we have 2 different number 3s. So we will list both of those. And then we have a 5. And then we have a 6. And lastly, we have a 7. Now, to find the median, you start crossing off points from either side, the same number, until you get to what is left in the middle. So if I cross a point off here and a point off here, and then a point off the left and the point off the right, you can see there are 2 numbers left. Now, if there was just 1 number left, that would be your median. But in this case, there are 2 numbers left. And so in order to find the median when there are 2 numbers left, you actually have to take the 2 numbers and you add them up and you divide by 2. And what you end up with is 3 plus 5 divided by 2, which is 8 divided by 2, which is 4. So our median for this data is 4. And it's pretty close to the mean. You can see the mean is 4.3 and the median is 4. Now the mode is going to be the number that is listed most often. You can have situations where if all the numbers are just listed once, there would not be a mode. But in this case, there is a number that is listed more than once. You can see this number 3 is listed most often. So the mode in this case would be 3. Now, the last thing that we're going to find for this data is the range. And the range is simply found by taking the biggest number and then subtracting the smallest number. So in this case, the biggest number we have in our data set is the number 7, and the smallest number we have in our data set is 2. And so when we do 7 minus 2, you can see we get 5, and 5 is our range. Now, the range tells us how spread apart our data is. And one thing to keep an eye out for is if you get a really big number for your range compared to your data points, that can indicate you have something called an outlier. And what an outlier does is it is a data point that does not really fit in with all the other ones. So as an example, you can see all of our numbers range from 2 to 7. And if I had another one that had a 25, let's say, hits, that number would be an outlier because it's not anywhere close to all of the other data points. And most of the time, when you do have an outlier, you end up eliminating it from your data before you go and find your measures of central tendency, which are your mean, your median, your mode, and your range. So let's try another one. Here's the second example I want to show you. Now, this one says analyze the stem and leaf plot displayed below and answer the following questions. So the first thing we need to make sure we understand is how a stem and leaf plot is made and or read. In this case, this is giving us the ages of some group of people. And the stem is going to be the first part of the age, and then the leaf is the second part of the age. And so what you actually can see is if I were to list all of these numbers out, we would start with the number 50. And then you can see we would actually have another 50 right here. So there's 5. So these are the first numbers, and then all of these are the second numbers. So there's quite a few numbers here. So I'm going to go ahead and list them. And since the stem and leaf plot has them in order, I'm going to list them out in order as well. So we would start with 50, and we cross that off. There's another 50, so we cross that off. Then 54, and then 57, and 59, and then 60, and 61, and 67, and then another 67, and then we would have 78, and then 80, 83, 84, 86, and then 87. And there are all of our points. Now, we have them listed from least to greatest. The nice thing about a stem and leaf plot is they typically have them listed from least to greatest too, so it's really not necessary to list all those out unless you really want to. Now, to find the mean, we will add all of those numbers up. So I'm going to go ahead and grab my calculator here and proceed to type all of those numbers in. So we have 50 plus 50 plus 54, plus 57, plus 59, plus 60, plus 61, plus 67, plus 67, plus 78, plus 80, plus 83, 84, plus 86, and then plus 87. And we get a total of 1,023. So 1,023 all added up. Now we need to determine how many points there are. And if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 points altogether. So now I'm going to go ahead and divide that 1,023 by 15, and I get 68.2. So our average age, or the mean age of our data, is 68.2. Now for the median, again, like I showed you before, you need to line them all up least to greatest and then begin taking numbers off the front and then the end, the beginning and the end, until you get to the center point. So if I do that, I'm going to probably cross out 5 at a time, at least 5. We'll do 6. 1, 2, 3, 4, 5, 6. And we'll start from this side. 1, 2, 3, 4, 5, 6. So now you can see we have 3 left, and I will cross one from the low end and the high end. And what you end up with right there is the number 67. And so since that's the number that's left, that number is our middle number, which is 67. And again, you can see the mean is 68.2 and the median is 67. So they're not the same, but they are relatively close. When that happens, most of the time, that indicates that there is no outlier. If there is an outlier, you will see the mean not be very close to the median. Now, the mode is going to be the most frequently occurring number. And there's an easy way to find that is you want to find all of your doubles. So there's 50 and 50. You can see here 67 and 67. And then there are no other doubles. So in this case, because there are 2 different numbers that were both listed more than once, there will be 2 modes. And the 2 numbers are going to be 50 and 67. Now, the range is found, again, the range tells us how spread out our data is, and it's found by subtracting the highest number and the lowest number. So in this case, the highest number we have is 87. The lowest number we have is 50. And so 87 minus 50 is 37. And there is how far our data is spread out. So that means there's 37 years between the youngest and the oldest person in our set of data. It says how many people are over 70 years old. So in this case, we would look at right here, we'd put a line. And anybody below that line, since this first number is 78, anybody below that line will be 70 or older. So you can see there are 1, 2, 3, 4, 5, 6 data points that are older. We could also go up here, 1, 2, 3, 4, 5, 6. You can see those people I just underlined are all older than 70. So there are 6 people. That's how you would answer that. Now, I do have one more example to show you. Actually, that's not true. I have 2 more examples to show you. This first one shows you the number of boxes of donuts that Maddie sold for a fundraiser each day for the last 11 days. And they want you to find the median, the lower quartile, the upper quartile, the interquartile range, minimum and maximum. So this is actually a review from whenever we talked about box and whisker plots. So let's go ahead. The first thing we need to do for box and whisker plot is to list our data least to greatest. So we will start by doing that. And you can see the smallest number we have here is 14. So I'll cross it off. And then it looks like the next number we have is 16. And then after that, we have a couple of 17s that we'll write. You do need to write them both. And then from there, we have, it looks to be 20. And then 21. And then 22. And then 26. 28. 29, and lastly, 35. So there's all of our data points from least to greatest. Now, they want to know what the median is. Well, to find the median, we're going to need to cross them off. So let's start by crossing 4 off. We'll do 5. 3, 4, 5. And you can see right there, there is our median. So the number for the median is 21. And the next number is going to be the lower quartile. The lower quartile is going to be found by splitting our data in half. So we need to look at the lower numbers first. And so when I split, because we can't split our data in half because it's not even, you will include 21 for each of those. So if I go ahead and erase, whoops, I didn't want to do that. I want to erase this. And then we'll look at all these. So the middle numbers here, cross 2 off, cross 2 off. You can see 17, there's 2 in the middle. When you add up 17 and divide by 2, you would still get 17. So the lower quartile is 17. We do need to do the same thing for the upper part. We'll cross this off, and we'll put a line right here, and we'll cross off 1 or 1, 2, 1, 2. You can see there's 2 numbers in the middle, 26 and 28. To find the upper quartile, because there's 2, we're going to add 26 plus 28 and divide by 2, and that will give us 54 over 2, which is 17. Now, the interquartile range is when we subtract the upper quartile and the lower quartile. Sorry, that shouldn't have been 17. That should have been 27, excuse me. Interquartile range is subtracting 27 minus 17, which gives us 10. The minimum is the minimum value, which is 14, and the maximum value is 35. And there we are. That's the final 2 numbers for this problem. Okay, so the last one is we're going to create a box and whisker plot from the data below. And so you can see they list a whole bunch of numbers here. And then we need to find the median, the lower quartile, the upper quartile, the interquartile range, the minimum, and the maximum. And once we find all of that, we can go ahead and create the box and whisker plot. So we do need to list our data from least to greatest first. So let's start by doing that. 58. And then we have 59. And then we have 61. And then from there, it looks like we have 63, 65. And then we have 66. Then we have 68, 70, 71, another 71, 72, 73, and that's it. Okay, so we will start by finding our median. And you can see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We have 2 numbers for the median. The 2 are 66 and 68. So when we do that, to find the median, we need to do 66 plus 68 divided by 2. That will give us 67. So that is our median, occurs right in the middle. Now, to find the lower quartile, we need to find the middle of the lower amounts of data. So we cross those off, cross those off. We have 2 numbers, 61 and 63. Once again, since there's 2 numbers in the middle, you have to add those 2 and divide by 2. And when you do that, you'll get 62. The upper quartile will be done in the same way. We will cross 2 off the bottom and 2 off the top. And you can see that we get 2 numbers. 71 plus 71 is going to be 142. When you divide that by 2, you get 71 again. So since the numbers are the same, that is your upper quartile. Now, the interquartile range is found by subtracting the upper quartile and the lower quartile. That gives you 71 minus 62 is 9. The minimum is the smallest amount, which is 58. And the maximum is the largest amount, which is 73. So now that we have all of our numbers that we need, we can proceed to go ahead and plot them all. So we need to we'll start with like 56 here, 58, and then 60, 62. We'll go to 64, 66, 68, 70, 72, 74, 76. So I'll put a dot on 58. I'll put a dot on 73. And then I will put a dot at each of the other 3 numbers, 62, then 67, and then 71. And what you can see is I have all 5 of my dots. I will draw in my whiskers first, and then the middle 3 points will be included in the box, just like this, and put a line through, and you have your box and whisker plot. So there you go, guys. I hope that made sense. And as always, if you have any questions, feel free to email me. Have a great day.